Hey, today we are going to take a look at sinus tachycardia. So we'll start off again taking a look at our EKG strips, and we're going to take a look here to see that first off it is a readable strip. And I can see that it is a readable strip. I am able to identify some waves, and I also note that it appears to be a 6-second strip. Okay, so let's go ahead and just make sure that we do have that 6-second strip. We had talked about this in some previous videos, but just to make sure, a lot of times paper does have marks like this, but in the event that it doesn't, we're looking for 30 of these big blocks, right? So we're looking for 30 of these big blocks, and that will actually tell us that we have a 6-second strip. So we have 1, 2, there we go. So this tells us that we are dealing with a 6-second time frame. Okay, so there's 15 blocks here, and we have 15 more blocks here. And when we bring that together, this is equal to a 6-second strip. Right, so it gives us an idea of things that we can take a look at. So we know that, yes, it is a readable strip. So next question we want to take a look at are P waves present or absent? So we can realize that that is a P wave, and we're just going to circle all of these wonderful little P waves here. And we can't see if there's one here, so that's okay. So P waves present or absent, and here we know that they are present. Is there a P wave for every QRS? And if you have recalled from some of our earlier segments, if you looked at some of the other segments, we realized that I like to go down from reading from left to right. So in this case, we're going to go P wave QRS, P wave QRS. After we have done that, we're going to reverse it. So now when we reverse it, we're going to go, is there a QRS for every P? So now when I do this, I'm looking to see that I have a P wave, or I'm sorry, a QRS for every P, and these are truly lining up. P wave for every QRS, and my answer here is yes. And do I have a QRS for every P wave? And my answer here is also yes. So now I need to take a look at what my PR interval is. And to do that, we're going to pull up a set of calipers. So we have everything cleared out of here so we can see and make... Okay, so we have our calipers, and we're now going to pull up here to see what our PR interval is going to do. So again, we're going to go from the beginning of the P wave to the beginning of the R wave, and that looks pretty good right there. So I'm going to move this down just so we can see it a little bit better, and I notice that this is at least 1, 2, 3. Looks like it's about 3 blocks. So if it's 3 blocks, 3 times 4 tells us that our PR interval is at 0.12. And what I want to do here, though, is I want to make sure that it's consistent the whole way down. So all I'm doing is verifying that where my PR interval is, that it is consistent. And I'm pretty confident, as we look at this, that it actually is. Okay. So we have verified, or have continuously verified through a 6-second strip, that in fact our PR interval is pretty good, and that PR interval is going to be at 0.12. Right? We said it was 0.12 because there were 3 blocks, and those 3 blocks times 0.04 is what's giving us this wonderful little thing right here of 0.12. Okay? We also found out that our PR interval was consistent. Okay? And we can verify this, that it was regular, but we're pretty confident that it was. So, but we're going to also take a look at this for a couple reasons, right? So I'm going to bring this down. I'm going to go on the peak of each one of those P waves. And now I'm going to move this, and we're going to see that that heart rate looks to be about 150, but I want to make sure that that stays consistent and that it is regular. And it does appear to be regular. Now, one of the things that we do want to bring up in this whole thing is that once in a while, particularly with fast heart rates, you may see that the the P waves may be off just a little bit. Okay, so like this one right here. So if you take a look at this, it's not exactly on. It may be half a block off. When it becomes a half a block off or something like that, this could be called, and actually we'll probably just move this up here, and we'll see that sometimes these things are actually called an R to R variability, right? So we have what is called an R to R variability. And what an R to R variability means, sorry, I gotta make sure I spell it right. So R to R variability means that you may have like 1 to maybe 0.5 of a block that is truly off. And this is okay. This usually tells us that this is probably related to a sinus rhythm, and usually this is something that we can help look at when we relate to a sinus tachycardia like this. So sometimes that does play a little role for us, and really it is better to just make sure that we're measuring with calipers, or we use what we'll refer to as the poor man's calipers, which is taking a straight edge with a piece of paper and just going down the whole way through, right? So we're going to answer this question here of regular, and we said yes. So remember, we were dealing here with the P waves. Our atrial rate, what we're taking a look at right now, is that we had a P2p interval, and we're going to bring this down right about here, okay? So we know that there is a wave that is right here, and there is a wave that is right here. So from this beat to this beat is 300. And then here is 150. And this is really right on. Again, where did we get this from? There are 1,500 small blocks in 1 minute, right? So when this goes across the stylus, and this again is at 25 millimeters per second, and when that occurs, that's when we get this whole wonderful little thing over here, 1,500 small blocks in 1 minute. Another way that you can do this is and this is how these numbers come out, right? Is that from this QRS complex here to this one is 5 blocks. So if I put 1,500 blocks inside the box and I divided that by 5, that actually comes out to 300. And if I did 1,500, again, this is a consistent number, and I divide it up by 10, that comes out to 150. So that's why this beat here, this atrial rate, is at 150. Now, I'm also saving myself some time, because if I move this and I notice that it is, and this happens 95% of the time, I never want to say anything is perfect, about 95% of the time, you're going to have the ventricular rate fall right in line, because you've determined that through the PR interval, everything has been pretty consistent, right? So that means that there is a relationship between the atria and the ventricles, and things should be working properly. And when we do that, we realize that the ventricular, the QRS complexes are normal, and their rate falls pretty good here at that 150 mark as well. While our calipers are here, we're going to go ahead and measure our QRS width. Okay, so I have from the beginning of my QRS complex, and we're going to just move this down here a little bit. And when I bring these together, and it looks like I'm at 2. So it looks like I'm at 2 blocks. So 2 blocks, or 2 small blocks, times 4 is 8. So therefore, my QRS duration, which we can mark right over here, is going to be 0.08. and we know that my QRS is regular, and my ventricular rate is at 150. Thus far, everything has fallen in line. So that means that I have a relationship between my P waves and my QRS complexes. I have a relationship there between the atria and the ventricles. So as a result of that, what I am now looking at is, by definition, a sinus tachycardia. And we know some things here that this is a sinus tach because I have a P wave, and therefore that means that it is coming out of the SA node. And I have a relationship here with my QRS complexes. So therefore there is a normal relationship, and this falls within the range of a heart rate that is greater than 100, so therefore it is a tachycardia. So all we have done is taken the definition of sinus because of the P waves, and we have now said that it is a sinus tachycardia. If you've watched any of my other videos, I kind of do this rudimentary diagram of a heart. Okay, so we have our heart, and we know that inside of our heart we are going to be dealing with our SA node. So we have our SA node that sits up here, and then we have our internodal pathways. We have our AV node, our bundle of His, our bundle branches, and then back to our... So let's go back here and just make sure that we're familiar with some things here, right? So the SA node is going to fire at an intrinsic rate of 60 to 100. Okay? The AV node is going to be firing between 40 and 60. And then these Purkinje fibers, okay, they actually fire at a rate around 20 to 40. Right? So those are the things that we know. Also keep in mind that up inside the atria, we know that there are other pacemaker sites. Okay? What we know, though, is that as a natural response, our heart has the ability to allow the SA node to speed up. So if it's firing at a rate of 60 to 100, this is considered to be normal. Okay? Now, however, when I have a P wave and I have a rate that is greater than 100, it is now considered to be abnormal, but because of definitions, it is now considered to be a tachycardia. Because I still have a P wave, it means that it is a sinus tachycardia. Now we know that our sinus tachycardia is occurring because it is greater than 100 and we have P waves. Sinus tachycardias can go greater than 100, but they also can go in excess of 150, and they can also go in excess of 200. So sinus tachycardias are coming out of the SA node. So they're out of the SA node. So when they are out of the SA node, that means that they always will continue to be a sinus tachycardia. So as long as you're following the rules, there's a P wave for every QRS, QRS for every P wave, PR interval falls within normal range, the QRS duration falls within normal range. That means that we have a sinus tachycardia. There is no rate that then makes this a SVT. So no rate automatically makes this an SVT. For this to be an SVT, it must come from one of these other pacemaker sites. So the problem, or multiple times I hear this, is that, oh, sinus tachycardias only go up to 150. Ladies and gentlemen, take a look at little kids. They have heart rates that are sinus tachycardias that definitely go over 200. In addition to that, sinus tachycardias are a reaction to something else. So in sinus tachycardias, when we talk about like this is considered to be a cold read, right? So I think I talked about this one before. So a cold read means that all I am doing is reading this EKG. I'm doing nothing else. I can't tell what is going on with the patient. So when I look at this, I have to take a cause for the sinus tachycardia to make a determination as to what the heck is going on with them. I have to answer the question, why is this sinus node going faster than what it's supposed to? It's abnormal when it is greater than 100. So what's the problem? There are multiple reasons why somebody can have sinus tachycardia. Our job as clinicians is to look for that and help fix it. So just a brief little overview of some things there with sinus tachycardia. Keep in mind, there is no magical number that says that once it reaches a certain rate, that it turns into an SVT. SVTs are coming from somewhere else, another pacemaker, technically another pacemaker that is going to be above the ventricles. That's what supraventricular tachycardia is all about, and we'll talk about that in another episode. Hope this was helpful. See you soon.